saying that given sine p plus sine q is equals to 7 over 5 and p plus q is equals to 90 degrees. Without using a calculator, determine the value of sine p. Okay, this question I can see what it needs because of that p plus q is equals to 90 degrees. What does that give us? It gives us that p plus q is 90 degrees. It gives us that p and q are cofunction. P and q is equals to 90 degrees gives us that p and q are cofunction. What is cofunction, people? Cofunction is that you should understand that 20 plus 70 is equals to 90 degrees, right? So we say 20 and 70, they are cofunction. Two things that you add them and get a 90, we call them cofunctions, right? So if p and q is equals to 90, it means that p and q are cofunction. So about cofunction, you should understand that sine of 20 degrees is equals to cos of 70 degrees, right? And also cos of 20 degrees is equals to sine of 70 degrees. So you should understand this about cofunction, right? So because they are saying x plus p plus q, so p plus q is equals to 90 degrees, it means what? It means that sine of p is equals to cos of q, right? And then cos of p is also equals to sine of q, right? So this is what that statement means. Because they are two cofunctions, it means that they are equal with the different trig ratios, right? They are equal with the different trig ratios, right? Okay, so because they want us to find sine of p plus, or let me write that is number 1, sine of p plus sine of q, plus sine of q is equals to 7 over 5. This is what they want us to, this is what they given us, right? So now they want us to find what? They want us to find sine of 2p, right? They want us to find sine of 2p, right? So to find sine of 2p, you should understand your double angle, right? So what is sine of 2p? Sine of 2p is 2 sine p cos p, right? So you can see that we only have p, right? So we need to change sine to be cos of p from this one that I've told you that sine p is equals to cos q. So I need to change sine q to be sine q to be cos p. Yes, this one I need to change sine q to be cos p because we are only dealing with p on our answer. We need to find everything in terms of p, right? So it's going to be what? It's going to be, therefore, what we have got sine p plus cos p is equals to 7 over 5, right? So to solve this, there is no other way. There's nothing we can do other than squaring both sides, right? Other than squaring both sides. We square both sides, sorry. We square both sides. So once we square both sides, this is the perfect square on the left, which is going to give us what? Remember the sine squared? It's going to be sine squared p plus 2 sine of p cos of p plus cos square p, and then is equals to, what is 7 over 5? 7 squared is 49, and then 5 squared is 25, right? So that is our answer. So we need to simplify this, right? We need to simplify. Remember, we are looking for this. So this one and this one, I can see that is our 1, right? It's a square identity, right? So I can write it as sine square of p plus cos square of p, and then plus 2 sine p cos p is equals to 49 over 25, right? So remember, now I've got this one, which is special, which is a double angle that I already knew, right? So I can just change this one to be my double angle. So this one, remember, is 1, right? So I've got 1 plus sine of 2p double angle is equals to 49 over 25, right? So after that, I can easily take the 1 to the other side. So it's going to be sine of 2p is equals to 49 over 25 minus 1, right? So what is 49 over 25 minus 1? It's going to be, this one is the same as 25 over 25. So it's 49 minus 25, right? So it's going to be sine of 2p is equals to 24 over 25, right? 24 over 25 is our final answer, right? So we've simplified for sine of 2p. So we need to go to the second question, guys. Just imagine me being your tutor. It will be very fun, right? So you should sign up and register to learn with us. I will drop the numbers where you can contact me underneath the video, right? Okay, but nevertheless, let's go to number 2. Number 2, what are they saying? Number 2, they've given us a Cartesian, no, they didn't give us a Cartesian plane. They're saying if cos of 2 theta is equals to negative 5 over 7. Cos of 2 theta is equals to negative 5 over 6. All right, cos of 2 theta is equals to negative 5 over 6. And then they are saying 2 theta is an element of 180 and 270. So it means that 2 theta falls on the third quadrant, right? Between 180 and 270 is the third quadrant. So they are saying without calculate without using a calculator the value of, in the simplest form of what? Of sine of 2 theta and sine squared of theta. Okay, so with this one, it's a Cartesian plane. Remember, we've already talked about where the which quadrant the Cartesian plane falls. So our Cartesian plane is on the third quadrant because they're saying theta is an element of there is our Cartesian plane, and then we know that cos is what? Cos is x over r. So our r is cannot be negative, is 6, and then our x is what? Is negative 5, right? So our x is negative 5 is 2. We don't know our y, right? And then here is our 2 theta, all right? So here is our 2 theta is the angle there, all right? So the first thing, because we know that sine is y over sine is y over r, so we need to calculate y first. So to calculate y, we're going to use Pythagoras, right? So r squared is equals to x squared plus y squared, all right? So our r is what? Our r is 6 squared, so it's going to be 6 squared is equals to, our x is 5, negative 5 squared, and then plus y squared, right? So 6 squared is going to be 36, and then this positive 25, when go that side, is going to be negative 25 is equals to y squared, right? It's equals to y squared. So now we need to simplify for y, so this one is going to be 11, right? So our y is going to be, remember when you introduce square root, it's going to be plus or minus the square root of 11, right? So now we need to use the negative or positive, and we know that we are on the third quadrant, and on the third quadrant y is negative, therefore y is equals to negative root of 11, right? So we now have our x, which is what? We now have our x, which is negative 5, and then our y, which is negative root 11, and then our r, which is 6. Remember, r is always positive, right? And then we know that sine of 2 theta is equals to what? Sine of 2 theta, sine is x over r, right? Is y over r, sorry. Sine is y over r, and then cos of 2 theta is what? Is x over r, sorry, not x. It's supposed to be r there. The denominator is always r, right? So it's y over r, and then this cos is x over r, and then the tan will be what? The tan of 2 theta will be y over x, y over x. So this is what we know, and then we've got all the information, so we can easily just punch into the just type it, right? So the first question, they're asking us to write what? 2.10 They want us to find sine of 2 theta. Sine of 2 theta. Remember, sine is what? Sine is y over r. So our y we've calculated it is root 11, right? Negative root 11, and our r is 6. So the answer is going to be negative root 11 over 6, right? So this is straightforward. That is why it have got 1 mark, right? So let's go to the next one. The next one is a bit challenging, right? So 2.2. 2.2, they're asking us to find sine squared of theta. Sine squared of theta. Remember, what we know is 2 theta, and then theta is half angle of the angle that we know, right? So whenever you need to talk about a half angle, you only apply the double angle of cos, right? Whenever they talk about a half angle, you apply a double angle of cos, right? So what does the double angle of cos gives us? A double angle of cos gives us cos of 2 theta is equals to what? Is equals to, remember, we need to talk about sine, right? So I will say 1 minus 2 sine square of theta. Remember the double angle of cos. It is there on your formula sheet, right? Double angle of cos is there on your formula sheet, okay? So after this one, now we can easily simplify for sine square of theta, because I know that cos of 2 theta is what? Cos of 2 theta is negative 5 over 6, right? This is negative 5 over 6 is equals to 1 is it minus 1 minus 2 sine square of theta, right? So the only thing that is left now is just to make sine square of theta subject of the formula, all right? So to make sine square subject of the formula, I'll just take this sine square to the other side. So it's going to be what? It's going to be 2 sine square of theta is equals to 1 plus 5 over 6. So 5 over 6 plus 1 is the same as 6 over 6 plus 5 over 6. So it's going to be 11 over 6, right? So I've got 2 sine square of theta is equals to 11 over 6. So after this, I can easily divide by 2. Remember, dividing by 2 is almost the same as multiplying by 1 over 2, right? So the denominator, this denominator will multiply the denominator. So I've got sine square of theta is equals to 11 over 12, right? So that is how you find your half angle, right? So remember, if they needed sine squared, if they needed sine of theta, it was going to be just divide square root both sides, right? So it was going to be plus or minus root 11 over root 12, right? So only because this time they didn't say they want sine theta, they said sine square of theta. But remember, theta is the half angle, right? And then in some cases, they will bring questions when we have got maybe when we know sine of 40 maybe is equals to, I don't know, let me talk about cos, right? Let me talk about cos. If you have got cos of 40 is equals to, let's say it's equals to 2 over 3, right? And then they want you to find sine of 20, right? They want you to find sine of 20. Remember, this is a lesson, right? Okay, if you are to find sine of 20, what do you do? Remember, 20 is the half angle of cos of 20, right? 20 is the half angle of 40. So to solve this one, what do? You apply again the double angle of cos. So it is going to be cos of 40. Remember, cos of 40 is the same as what? Is the same as cos of 2 multiplied by 20. This one I'm just showing you where it comes from, right? Cos of 40 is the same as cos of 2 multiplied by 20, right? So remember, we ignored that we're dealing with sine of 20, but we'll bring it later, right? We start by double angle of cos, right? So what is cos of 40? Cos of 40, we know that is 2 over 3, right? We know that is 2 over 3. So is equals to, what is this double angle now? What is cos of 2 multiply, what is this one when we expand it as a double angle? Remember, we now check here, we're looking for sine 20, right? So when we expand this one, it's going to be 1 minus 2 sine of 20 degrees. Sine squared, sorry, is sine squared because it's a double angle, right? So it's the double angle of sine, so there it is, right? So from here, what do? We take this to make subject of the formula, so it's going to be 2 sine squared of what? 2 sine squared of 20 is equals to 1 minus 2 over 3. 2 over 3. So now we can divide by 2, or let me start by simplifying. So it was going to be 2 sine squared of 20 is equals to, this is 3 over 3 minus that one, so it's 1 over 3, right? So now we divide by 2, divide both sides by 2. So it's going to be sine squared of 20 is equals to 1 over 6, right? 1 over 6. So to get rid of the square root, we make squared, we make square root, and we make plus or minus, right? So it's going to be sine of 20 is equals to plus or minus root of what? Root of 1 over 6, right? Root of 1 over 6. 1 over 6. So remember, this was just an example because root 20 is really not equal to this, right? And then root cos 40 is not really equal to that. But I was just showing you how you can apply the half angle, right? This is how you can apply the half angle. And then we applied the half angle here, and then we got this answer. This is the answer for number 2.2. So let's quickly go to number 3. Let's quickly go to number 3. Let's quickly go to number 3. So with number 3, what are they saying? They're saying in the diagram above, P, which is the coordinate x is to -9, is a point on a Cartesian plane such that OP is 15. Okay, we've got R as 15, and then units. Okay, and then S, there's S there, lies on OP. It's on our OP, which means that it have got the same angle, which is theta, right? It means that OP have got S have got the same angle, which is theta. R is a point on the positive x. Where is R? Okay, R is the point on the positive x-axis. Means that, okay, they just want to show us that PR is theta, how to measure our angle, right? Okay, and then they say determine with the aid of a diagram the following: the value of x. So the value of x, we know that our Pythagoras says R squared is equals to x squared plus y squared, right? So what is our R? They've given us that our R is 15. So we've got 15 is equals to, what is our x? Our x is the one that we are looking for. And then our y is the one that we know, which is -9, right? -9 squared. So to simplify this, I'm going to have this. So 15 squared is 225, right? 225, and then 9 squared is 81. And then when you bring that side, it's going to be negative, right? Is equals to x squared. So what is this minus this? 80 minus 200 is 140. 5 minus 1 is 40. So I've got 144 is equals to x squared. So now I introduce the square root. It's going to be plus or minus. So it's going to be x is equals to plus or minus the square root of 144 is 12, right? Okay, so what is the answer of what do we choose? Because P is on the third quadrant. On the third quadrant, both x and y are negative, so it's -12, right? Okay, so now we've got our x, y, and r, right? So when they say find the tan of theta, remember previous question, okay, we know that this is 3.1. They want us to find tan of theta. So tan of theta, remember, tan is what? Tan is y over x. So our y is what? Our y is -9, and then our x is -12. All right, so this is going to be, we can divide by -4 both sides. So it's going to be -3 by -3, right? So it's going to be 3/4. Yes, so the answer is 3/4, right? And it have got 1 mark, right? Okay, so let's go. Even if you write it, it means even if you write it without simplifying, you get the same mark, right? Now they want the value of S, all right? They want the value of C. They want the value of C, which is on the coordinate S, right? So if we've got two things on the same line, right, on the same line everywhere, even if it was here, right, if we've got this point and this point and this point, right, because they share the same angle, because they share the same angle, right, it means that x over y from this point and x over y from this point and x over y from this point, they are all equal, right? Because they share the same angle, all the x over y's are equal, or the y over x's are equal, right? So we just say x1 over y1 is equals to x2 over y2. Just like that, we get our answer, right? So this is 3.1.3, 3.1.3. This was 3.1.2, right? 3.1.2, right? Because this one was 3.1.1. Yes. Okay, so 3.1.3, we know that x1 over y1 is equals to x2 over y2. So what is our x? Our x is, we calculated our x, it was negative 12 over y2. Our y2 is negative 9. So it's equals to x2. x2, I'm going to talk about the ones on S, so it's negative 2 over c. So we need to solve for c, right? So it's going to be 12c, negative 12c is equals to 18, positive 18, right? So we divide by 12, we divide by 12, negative 12 by negative 12. So our c is going to be what? I think 16, we can divide it by 3, it goes 6 times. Okay, I think we can divide by 6. Yes, 6 goes 3 times and then 6 goes 2 times. So I've got negative 3 over 2. We've got negative 3 over 2 is our value of c. So our value of c is negative 3 over 2. So we are done with this one, right? Let's quickly go to number 4. Let's quickly go to number 4. Number 4, the only thing that is very important is to understand your quadrants, all the 4 quadrants of a Cartesian plane. Make sure that you understand your cast diagram. Make sure you understand the angles on each quadrant, right? And then understand that if you have got angles bigger than 360, you just remove 360 when you bring it down, right? And then if you've got any negative angle, before you start working with the negative angle, you bring it to the 4th quadrant, right? Before you start working with the negative angle, you bring it to the 4th quadrant and then you remove the negative. Like if I've got sine of negative 300, it means that I will start by saying what is sine on the 4th quadrant is negative. Then I remove that negative, then I remove negative behind, so then it comes negative sine of 300, right? But okay, let's see if we're going to apply that in this question. So they're saying tan of 180 plus. Tan of 180 plus, it will become what? Tan of 180 plus, 180 plus is the 3rd quadrant. So tan on the 3rd quadrant is positive. So this one is just going to be tan of theta, right? Tan of theta, and you deserve a mark for that, right? And then the second one, they're saying cos of 360 minus. 360 minus is on the 4th quadrant. On the 4th quadrant, cos is positive. So we've got cos of theta. And then let's go to the next one. The next one, they are saying sine of 180 minus theta. So what is 180 minus theta? 180 minus theta is the 2nd quadrant. Sine on the 2nd quadrant is positive. So we've got sine of theta. It's a mark also. Already we have accumulated 3 marks out of 9, right? And then they say cos of 90 plus. 90 plus is on the 2nd quadrant. Cos on the 2nd quadrant is negative. And because it's 90, it's a cofunction, right? 90 means cofunction. So 90 plus is going to change to sine, right? And then remember, cos on the 2nd quadrant was negative. So it's going to be negative sine of theta, all right? So now we've got plus 360. We remove 360 from 520. What do we have? We now have 180, right? So this is the same as cos of 180 plus theta. So what is 180 plus theta? 180 plus theta is the 3rd quadrant. On the 3rd quadrant, cos is negative, right? So this one's going to be, I'm just going to write minus here, cos of theta. Right, we'll go to the second one. They say cos of negative angle. Cos negative angle, I told you that we deal with it as if it is 4th quadrant. So cos on the 4th quadrant is positive. So it's just going to be cos of theta. So already we accumulated how many marks? Let me show you the marks that we have accumulated up to so far. Accumulated 1, 2, 3, 4, 5, 6. So we have accumulated 6 marks already with the first step, right? We have accumulated 6 marks already with the first step. So now we need to do what? Okay, we know that tan, it can be written as sine over cos, right? We accumulate another mark for writing sine theta over cos theta in space of tan theta, right? Multiplied by cos of theta over what is sine, multiplied by sine, and then the other is negative, so we've got negative sine square of theta, and then cos and cos, we've got minus cos square of theta, right? So again, we accumulate 2 marks, right? Changing this one, it's a mark, right? And then we accumulated 1, in fact, yes, and then this and this will cancel out, right? So these two is the same, they've got the same sign. Whenever they've got the same sign, you factor out negative. If they've got different signs, you make them cos square minus sine square, which is a double angle of cos. Remember that, right? That is very crucial. If you have got sine square and cos square, if they've got the same sign, you know that that is going to be 1. If they've got the same sign which is positive, it means that it's going to be positive 1. Like these ones, they've got the same sign which is negative, it means that it's going to be negative 1. So you can easily change it to negative 1, but I'm going to show you why it becomes negative 1. But if they've got different signs, like if you have got, I'm going to rub this again, right? So if you have got sine squared of theta minus cos square of theta, you can see that they've got different signs, right? So if you want to write this in one trigonometric ratio, right? So it means that you start by what? You need to start by cos. So it's going to be negative cos square of theta plus sine square of theta. So you factor out negative, it's going to be negative cos square of theta minus sine square of theta. So because this one, you know, is a double angle of cos, so this one is going to be negative cos of 2 theta. Don't forget that, right? This one is negative cos of 2 theta. Do not forget that. That is very crucial, right? That is very crucial for you to remember, right? Okay. But now let's go to our equation, because they've got the same sign here. I'm sure if it was sine square plus cos square, you was easily going to see that it is 1, right? So this one, because they've got the same signs, it means that you can factor out negative here. So on top we'll be left with only sine theta, right? On top we're left only with sine theta. And then on the bottom, it means that we're going to say factor out negative, and then it's going to be negative, and then inside we're going to have what? There's no need for me to write 1, right? We're going to have sine square theta plus cos square theta, right? So after that, we know that this is 1, all right? So this one is going to be negative 1, right? So what do we have? We've got negative 1 on the denominator, right? So it means that I've got sine of theta over negative 1, which gives me what? Which gives us negative sine of theta. So that is it. We've got our answer, right? So do not make a mistake. Understand that if I've got sine squared and cos squared, if they've got the same sign, it means they are 1. If they've got different signs, it means they are double angle of cos, all right? Do not forget that. So let's go to the next one. The next one, they are saying, show without using a calculator that sine of 15 is equals to that, okay? Without using the calculator, it's number 5, right? It's number 5, guys. Just imagine me as your tutor. Where would you be? Imagine me as your tutor. Where would you be? Just register with my classes. Make sure that your parents inquire. Don't inquire as a learner. Give my numbers to your parents, and then they will inquire with me. I will definitely help you, right? I will definitely help you. You will see changes very quickly, right? You will see changes very quickly. Inquire with me. I will help you with mathematics, and you will succeed, right? Okay, fine. Let's go to number 5. So number 5, we've got sine of 15. We've got sine of 15 degrees is equals to, let's prove that this is equals to root 6 minus root 2 over 4. So we need to prove this, right? Okay, So there are two ways to prove this one because it's 15, right? Because it's 15, there are two ways to prove this one. One way is to apply the double angle, right? Is to apply the double angle because I know that what is sine of 30, right? So is to apply the double angle, and then another way is to do what? But with the double angle, it will be confusing, okay? But we'll try it as well, right? But the normal way is to use a compound angle, right? Normal way is to use a compound angle. If you see that this angle, you can find it by compound angles. Yes, I can find it by 45 minus 30 or 60 minus 45. So I prefer 30, right? So I'm going to use 45 minus 30. So this one is the same as sine 15 degrees is the same as sine of 45 degrees minus 30 degrees, right? So now let's expand our compound angle, right? So let's work on the RHS, expanding our compound angle. So sine with a plus, remember sine is sine cos cosine, right? Sine cos sine cosine. So it's going to be sine of 45 degrees cos of 30 degrees, and then because it's a minus, we're going to have a minus cos of 45 degrees sine of 30 degrees, all right? And then what is the answer of sine 45? Remember, special angle of sine 45 is 1 over root 2. And then what is cos of 30? Cos of 30 is root 3 over 2. And then minus what is cos 45 is also cos 45 is also 1 over root 2, right? Cos all of them, cos 45 is the same, right? Multiplied by sine of 25 is 1 over 2, right? So multiplying the 2 is going to be 1 multiplied by root 3, so it's going to be root 3 over 2 root 2, right? Then minus, let's go to the next one. The next one we've got root 2, so it's 1 multiplied by 1 on top, and then 2 multiplied by root 2, so I've got 1 over 2 root 2, right? So after that, what do we have? Then we can when we add the 2, remember they've got the same denominator, so I've got root 3 minus 1 over 2 root 2, all right? So now we need to rationalize the denominator. It means that we can easily multiply by 1, all right? So 1 can be written as anything. Remember, multiply by 1 doesn't change anything, right? So it's going to be root 3 minus 1 over 2 root 2 multiplied by root 2 over root 2, right? So denominator root 2 multiplied by root 2 is going to be 2. 2 multiplied by 2 is going to give us 4 on the denominator, right? And then root 2 multiplied by root 3, remember, if you're multiplying the same roots, you can easily multiply the inside of the root, right? So it's going to be 3 multiplied by 2, which is going to be root 6, right? And then negative 1 multiplied by root 2 is going to be minus 1 root 2. So there we are. We have proven our identity, right? We have proven that our sine of theta, sine of 15 is equals to this, right? Not identity. We have proven that sine of 15 is equals to that one using the special angles, right? Okay, so let's go to number 6. Number 6, they are saying what? Number 6, they are saying that we have got show that sine of 33 degrees over sine of 11 degrees minus cos 33 minus cos of 33 degrees. What's going on? Okay, minus cos of 33 degrees over cos 11 degrees is equals to 2. We need to prove that, right? So in order to prove that, remember we've got two fractions, right? So to add the two fractions, remember if you have got 1 over 2 plus 3 over 5, this is the method that I teach only higher grades, right? 3 over 5, more especially grade 11 and 12, right? If you want to add this fraction, you can just do this, right? So it's going to be 1 multiplied by 5, which is going to be 5, and then 2 multiplied by 3, which is going to be 6 over 2 multiplied by 5 over 10. So the answer is 11 over 10, right? That is how I'm expecting you to do these kind of things, right? To add the fraction, add or subtract the fraction, right? So this one's because we are subtracting them, So let's get down and subtract them. All right, let's get down and subtract them. So it's going to be what? It's going to be the cross multiplication. So it's going to be sine of 33 degrees cos of 11 degrees. Then minus cos of 33 degrees sine of 11 degrees all over sine of 11 degrees cos of 11 degrees. Remember, we are working with the LHS. Remember, you should show that you are working with an LHS left hand side, right? So after this one, I can see I've got sine cos sine. The angles are the same, is 33 and 11, right? So I've got a compound angle of sine. So with a minus, it's going to be minus inside, right? So it's going to be sine of 33 degrees minus 11 degrees, right, over sine of 11 degrees cos of 11 degrees, right? So after this one, what is 33 minus 11? Is going to be 22. So I've got sine of 22 degrees over sine 11 cos 11, sine 11 cos 11. So can I relate 11 and 22? Yes, 22 is a double angle of 11. So I can change that sine to be a, sine 22 to be a double angle. So it's going to be sine of 2 multiplied by 11 degrees over sine 11 cos 11 degrees, right? So here it is, right? So now I can expand the double angle there on top. So it's going to be 2 sine of 11 degrees cos of 11 degrees over sine of 11 degrees cos of 11 degrees. Right? So now cos and cos will cancel and sine will cancel. Then we'll have our 2 as an answer. Right? We'll have our 2 as an answer. So it means that sine of we have proven that our left hand side is equals to our right hand side, right? So this is how we proved it. We use a double angle, but we started applying the adding fraction. This is very important, right? If you've got 2 over 5 and then is 2 over 5 and then plus 3 over 7. All right, so if you want to add this, remember you cross multiply and then multiply the denominators. It will help you, right? It will definitely help you to do it in that way, right? So now let's go to the next one. The next one they want us to prove. Number 7 is also proof, right? Number 7, guys, just imagine with me doing this like this, doing things like this with you watching, and then asking exactly what you don't understand, like what's going on there, and then I explain to you. Do you think maths will ever be difficult for you? It will never ever be difficult for you, right? If you join our online classes, math, it will never ever be difficult for you. Okay, let's just go to number 7. Number 7, they're saying sine of 45 degrees plus x, sine of 45 degrees plus x. Okay, and then we've got sine of 45 degrees minus x. But sine of 45 degrees minus x. So here I can see that I've got a compound angle. There's nothing, no way I can solve this other than a compound angle, right? Okay, and then is equals to 1 over 2 cos of 2x is equals to 1 over 2 cos of 2x, cos of 2x. Okay, so that is the double angle, but if I expand the double angle, I won't be getting the compound angle, so I need to work with the left hand side, right? I need to work with the left hand side. So with the left hand side, I'm going to expand the two compound angles of sine. Remember, the first one is plus, going to be plus, second one is minus, going to be minus. Sine cos cosine, right? It's going to be, the first part is going to be sine 45 degrees cos x, then because it's a plus, going to be plus cos 45 degrees sine x, right? And then after that we've got sine 45 degrees cos x, and because it's a minus, going to be minus sine 45 degrees, 45 degrees. No, not sine 45. I'm making a mistake, right? It's sine cos, cos sine, right? So it's going to be cos 45 degrees sine x, right? So there it is, right? So we need to simplify the two, right? So I will start by this one. What is sine of 45? It's going to be 1 over 2. 1 over root 2. We all know that it's a special angle. It's a special angle. So I will go to the next one, which is going to be, okay, cos x. That's nothing we can do. Then we've got cos 45, which is also 1 over root 2. So I've got plus 1 over root 2, and then sine of x. And then we'll go to the next one, which is sine 45, which is also 1 over root 2 cos of x. Then we'll go to the next one, which is also minus 1 over root 2 sine of x. Right, so there we are. Right, now we need to multiply the two. So this multiplied by this is going to give us what? It's going to give us 1 over root 2 multiplied by 1 over root 2. 1 and 1 will give us 1, root 2 and root 2 will give us 2. So I've got 1 over 2, and then cos x multiplied by cos x is going to be cos square x, right? And then we've got this one and this one, which is going to be 1 over 2 sin x cos x. It's going to be plus 1 over 2 sin x cos x, right? And then it's this one and this one, right? So it's a minus, so I made a mistake by writing a plus there. It is supposed to be a minus, right? It's supposed to be a minus here. So there it is, it's a minus, right? It's a minus. And then we've got this and this now, so it's going to be plus the same thing, right? 1 over 2 sin x cos x, right? And then now we've got this and that, so it's going to be minus 1 over 2 sin square x, right? So these two is the same thing, the other with a minus, the other with a plus, so they are going to be cancelled, right? They're going to cancel each other out. So what do we have? Got 1 over 2 cos square x, and then I've got this one, which is minus 1 over 2 minus 1 over 2 sine square x. So there it is. So now we can easily factor out 1 over 2, right? If we factor out 1 over 2, remember I told you if you have got cos x and sin x and they've got different signs, it's a double angle of cos, right? So it's going to be 1 over 2. Then I've got cos square x minus sine square x, right? So that is our double angle of cos. So I've got 1 over 2 cos of 2x, right? So I've proven our left hand side is equals to the right hand side, right? So we needed only, what we needed was to expand the two compound angles, right? And after expansion, we know we need to simplify, right? So that's it, guys. If you know, if you join us, do you think this one was gonna be easy for you? And then it will be very easy for you to pass your mathematics. You'll get very high marks, right? Just make sure that you contact me and join our online classes. It's 5 sessions per week, right? 5+ sessions per week, because like this week, because learners are writing mathematics and physical science next week as their examinations, March examination. I will also I have to assist them Friday and Saturday, right? Friday, Saturday, Sunday, and Monday I will be very busy with the learners from grade 11, 10 and 12, 10 to 12, right? Okay, now let's go to number 8. Number 8, they are saying cos of A minus B is equals to, okay, is given that cos of A minus B is equals to cos A cos B plus sin A sin B. That is a compound angle of cos, right? So they are saying use cos A minus B to derive the formula for sine of A minus B. Now we need to derive the formula of sine of A minus B. Okay, so we are deriving the compound angle of sine. by the compound angle of cos, right? So it means that I know that sine of A minus B, right? Sine of A minus B is equals to what? Is equals to cos of 90 minus A minus B, right? That is what I know. Okay, this phone is giving me, it is muting the mic. I don't know, right? Okay, let's see, maybe I will have my voice audible. Okay, so that is what we have, right? So now we know that sine of A minus B is equals to this, because if you put 90 minus, it's a cofunction, right? It's a cofunction, so we need to work left hand side. If you work left hand side and prove that the left hand side is equals to what do we call okay, they didn't give us anything, right? So saying let's just derive, but we know the formula of sine A minus B is what? Is sine A cos B minus cos A sine B, right? So that is what we need to prove, right? Okay, so let's work with the RHS. Right, with RHS, I've got cos of 90 minus A minus negative B, right? Because I took in the negative, it was gonna be a positive there, but if I take the positive in, it will be it will not give us what we want. So this is what you have to do if you need to prove, right? Remember, when you come to prove, there are some things that you even need to cram, right? Because I just took in the negative, changed this to be negative, but when it come here, I didn't multiply it with this negative, I left them as they are, right? So remember, you can still multiply them, but we don't need to multiply them because we are proving, right? We are proving the identity, right? So what is cos A minus 9? Okay, we come here and say cos of 90 degrees minus A, we put them into the brackets, right? Minus negative B. So there we are, right? This is what we have now, right? So they've already given us there on top, they say it's supposed to be cos and then with a plus in between, right? So we know that it's going to be cos 90 degrees minus A and then cos of negative B, right? Cos of negative B. And then because it's a minus, we use a plus here in between, right? So it's going to be sine of 90 degrees minus A and then sine of negative B, right? So there we are, right? So now we need to simplify this and see if it's going to really give us the double angle of sine. So what is cos of 90 minus A? Is going to be sine of A because it's on the first quadrant, right? Okay, and 90 is the cofunction. So what is the cos of negative B? Cos of negative angle, it remains a positive because cos on the fourth quadrant is positive. So this one is going to be cos of B, all right? And then we've got a plus here. And then what is sine of 90 minus A? It's going to be positive sine of A, right? No, it's going to be cos, sorry, it's 90 minus, it changes to be cos, cofunction, right? So it's going to be cos of A, right? So sine of negative B, remember, is negative sine of B, right? So we factor out the negative, so I've got sine of A cos of B and then minus cos of A sine of B. So there we are, we've proven our identity, right? We have proven, let me use therefore is what we needed to prove sine of A minus B. Sine of A minus B is equals to sine A cos B minus cos A sine B. All right, so we have proven a compound angle of sine, right? So now let's go to 8.2. This was 8.1, sorry, this was 8.1. Okay, 8.1. Let me show that this is 8.1. So now let's go to 8.2. Let's go to 8.2. Remember, if there's something that I'm doing you don't understand, feel free to contact me. There's always my number on this video, right? There's always my number on this video. Feel free to contact me. 07914442266. So let's go to number 2. They're saying sine of x plus 64. Sine of x plus 64 degrees. Cos of x plus 379. Cos of x plus 379 degrees. And then sine of x plus 90. The plus is plus sine of x plus 90 degrees. And then no, not 90. Sine of what is sine of x plus 19. So why am I saying 90? 19 degrees. And then we've got cos of x plus 244. Cos of x plus 244 degrees. Right? So what are they saying? They are saying cos of x plus 244 degrees is equals to 1 over root 2 is equals to 1 over root 2. Okay, this is too long, right? So they need just to show that, okay? They're saying show that for all values of x. It means that we will see what they mean when they say for all values of x by just simplifying the left-hand side. We simplify the left-hand side, then we will see. So there's nothing, absolutely nothing I will do on the first one. So the first one, I'm just going to copy it as it is. It's going to be sine of. Okay, remember, let me show that I'm working on the LHS again. All right. So the first thing, there's nothing I can do with this one. It is just going to be sine of. Okay, it's fine. Nope, this angle is 64. And then sine cos. Okay. And then remember, because I've got sine cos and cos sine, it means that for me it looks like a compound angle of a sine. And then compound of a sine, I know it by sine cos cos sine, right? So I will definitely start by trying to make it sure sine cos cos sine, right? So it's going to be sine of, sorry, so it's going to be sorry, I'm muting the mic here. Okay, so it's going to be sine of x plus 64 degrees, right? And then this one is going to be what? Remember, I told you about removing the 360, right? If you have got an angle bigger than 360, you can easily remove the 360. So that one is the same as cos of x plus 360, right? So it's the same as cos of x plus 360. So it's the same as cos of x plus 19, right? Because I'm removing the 360, it's going to be 19 degrees, right? So with that other one, I want to start with cos because I want it to be cos sine, right? So it's going to be plus, and then because it's cos of x plus 244. So from 244, I want to remove 180, which means it's going to be 180 plus, and 180 plus is on the fourth quadrant, and cos on the fourth quadrant is going to be negative. So here it was supposed to be a negative cos of x plus, what is 180 minus 244 is going to be 64, right? So it's going to be 64 degrees, right? And then now we've got a sine of x plus 19 degrees, right? So there it is. This is what I have. Now I have my sine cos cos sine, right? I have my sine cos cos sine, right? Remember, I've got my cosine, I've got my sine cos cos sine. So this looks like a negative. Okay, yes, like this. So it means, and then we've got a negative. Remember, if you have got sine cos cos sine with a negative in between, it's a minus in between, right? So my angles is this one minus this one, all right? So it's x plus 64 minus x plus 19, all right? So it's going to be what's going to be sine of x plus 64 degrees minus into x plus 19 degrees. There we go. All right, so after this one, what do we have? We've got a sine of x plus 64 degrees minus x minus 19 degrees. All right, so what is the answer? It's going to be sine of x minus x is 0, 64 minus 19 is 45, right? Yes, it's 45 because minus 9 is 55, minus 10 is 45. Yes, 45 degrees. So the 45 degrees is a special angle, which is 1 over root 2. So we've proven the identity, right? We have proven that this identity is really equals to 1 over root 2, right? So it was just applying the compound angle of, we just needed to apply the compound angle of sine, right? So we are done with question number 8. Let's go to question number 9. Question number 9, they are simplified to a single trigonometric ratio. We've got cos of x minus 180. Cos of x minus 180, number 9. Okay, number 9, we've got cos of x minus 180 degrees. And then plus root 2, plus root 2, plus root 2, sine of x plus 45. Sine x plus 45 degrees. It's like this, right? Yes. Okay, the first one, there's no need for us to do a compound angle, right? It's just a reduction formula because of the angle 180. But the second one, because of 45, the only way to solve that one is to use a compound angle, right? So 180 minus is on which quadrant you don't know, right? So if you don't know, you go into your calculator, you punch any angle between 0 and 90 for x, right? And then you say minus 180. Any angle between 1 and 89, between 1 and 89, in fact, because we don't include 0 and we don't include 90, right? So you go into the calculator, you say cos of, where is cos? You say cos of, okay, cos of, I'm just going to be 2 minus 180, right? 180. So what is the answer? The answer is negative, right? 2 minus 180, the answer is negative. So it means that this one is going to be negative cos, right? You just write it as negative cos, you got your mark, right? It's just going to be negative cos of x. You'll get a mark for this, right? So let me write it backwards because I think that this one will be long and I don't want it to be so long. Okay, is equals to negative cos of x, right? So we've got plus root 2 into expanding the compound angle, which is inside the brackets. Sine of x plus 45 is going to be sine cos sine, right? It's going to be sine x cos 45 degrees. And then because it's a plus, we are going to use a plus also, right? We are going to use a plus. So it's going to be cos x sine 45 degrees, right? So there we are. So now we know we have got negative cos x plus root 2 plus root 2 into what is sine, okay, what is cos 45? Cos 45 is 1 over root 2. 1 over root 2 multiplied by sine x is 1 over root 2 sine x. 1 over root 2 sine x. All right, 1 over 2 sine x. And then plus, what is sine 45 is 1 over root 2 multiplied by cos x is over 1 over root 2 cos of x. All right, so if we multiply these two, this and this will cancel. Again, if we multiply this and this will also cancel, right? So what are we going to have? I'm going to have negative cos of x plus sine of x, and then okay, and then plus cos of x. Yes, plus cos of x, and then I've got cos of x and cos of x. The other is positive, the other is negative, so they're going to cancel out. So my answer is sine of x. My final answer is sine of x. Remember, even this one, you needed to apply the compound angle. Remember, you cannot run away from compound angles once you are in grade 12, right? Once you're in grade 12, the thing that you work with is compound angles, right? So all my learners, I'm sure all my learners now understand the compound angles. That is why I'm asking you to come and join us, right? Join us while there is still time. Join our online classes. It will definitely help you, right? Okay. So with this one, they want us to prove the identity. Okay. So it's 1 minus tan square theta over 1 minus tan square theta. 1 plus tan square theta is equals to cos square theta. Okay, we need to prove on the left hand side, we need to get rid of this tan, right? But the first thing that I need to get rid of, looking at this, right, is this one. I need to make it one fraction, right? But okay, let me tell them that, let me show the exam. The person who's going to mark that I'm starting by working on the left hand side. Remember, one can be written as x over x depending on what you're adding. I told you if you've got 1 plus 3 over 5, you know that this one is the same as 3 over 3 plus 3 over 5, right? So the answer is going to be what? And not 3 over 3. Remember, you take the denominator. It's going to be 5 over 5 plus 3 over 5. So you're going to add the numerator, is going to be 8 over 5. The answer is 8 over 5. Remember this one can be changed to be written as the denominator over denominator, right? What is the denominator on the other side? You write it as a numerator on the other side. So the denominator is this one. So I'm going to write 1 as 1 plus tan square theta over 1 plus tan square theta, right? So it's going to be what? The left hand side is going to be 1 plus tan square theta over 1 plus tan square theta, right? Minus tan square theta over 1 plus tan square theta, right? So because we've got the same denominator, it means that we can add the numerators, right? So I've got 1 plus tan square theta minus tan square theta over 1 plus tan square theta, right? So that is our left hand side, right? So tan square theta and tan square theta will cancel out on the other side, on the top. So because this is the same thing and the same thing, so they will cancel out, right? So I'll be left with 1 over 1 plus this tan square theta. I'm changing it to be sine square over cos square, right? So it's going to be sine square theta over cos square theta, right? So remember, if I'm adding 1 plus x over y, this is the same as y over y plus x over y. So it means that I'm going to add the numerators. So it's going to be, okay, so let me write it here. So it's going, this is the same as what? This is the same as y over y plus x over y. I've changed this to be the same denominator with this one, right? So after adding them, what do I have? I've got y plus x over y, right? So that is what we do. Because I've got this cos as a denominator, I'm going to use it as a numerator, as a fraction, right? So it's going to be what? It's going to be 1 over this one. I'm changing this one, remember, to be what? To be sine over your cos over cos, right? So I've got cos square of theta over cos square of theta plus sine square of theta over cos square of theta. All right, so now it means that I can easily add the numerators. So this time now I didn't put in brackets because it was visible what is going on because of this long division, right? Because now I no longer have that one, so I'm going to use 1 over, I'm going to use the brackets now, right? I need the brackets because on top I've got cos plus sine, cos square theta plus sine square theta over cos square theta. All right, so remember sine square and cos square, if we are adding them, if they have got the same sign, it means that they are 1. If they've got different sign, it means that they are double angle of cos. So these ones have got the same sign, all positive, right? So what I have now is 1 over 1 over cos square of theta, right? So now I change this division line to be multiplication, right? So it's going to be what? It's going to be 1 multiplied by cos square of theta over 1, right? So this gives us cos square of theta. Did we prove the identity? Yes, the identity wanted us to prove that is equals to 1 over cos square theta. So this one was basically mostly about understanding this aspect, right? Adding 1 to a fraction, right? Adding 1 with a fraction, or adding 1 to a fraction. This is a key for this answer, right? This was a key for this question. This was the only thing that we did that was looking like it is a bit challenging, although it is not challenging, right? Okay, so let's go to number, this was number what? Okay, we're going to number 11. Okay, we moved very fast, so let's go to number 11. Guys, make sure that you join these classes. Make sure you join our online classes as we go to number 11. Okay, number 11, they're saying use question 10 to determine the general solution of. We are using what? We are using number 10. So on number 10, you can see what we have there is 1 minus tan square over 1 plus tan square. So it's the same thing. If we expand, if we try to simplify that, we're still going to get cos square. But the only difference here is the angle. So because we never worked with an angle in the previous question, it means that even here we're not going to work with an angle. All right. So we just know that what they mean there when they say use question 10, it means that we know that everything that they've written there on the left hand side for number 11 is everything that is there on number 10, right? So on answering number 11, the first point is to replace 1 minus tan square of x over 2 over 1 plus tan square of x over 2 is equals to 1 over 4 by what? By cos square. Is what? By cos square of theta is equals to 1 over 4, right? That is our starting point. Cos square of theta is equals to 1 over 4. So they will give you a mark by replacing, by just writing cos square of what is our angle is x over 2. X over 2 is equals to 1 over 4. They will give you a mark because you applied what you had from the previous question, right? So you'll get a mark but there's no need for you to start by simplifying again, because if you started to simplify again, you were still going to get this answer and you knew it, right? Because you already worked it out, right? Okay, so now let's go to answering the question, right? Let's go to answering the question. So we need the general solution. They say determine the general solution. Remember, to find the general solution, we cannot find the general solution if we've got cos square. We need to have cos equals 2, right? So to have cos equals 2, I will introduce square root both sides, right? And remember, when you introduce square root, it's going to be plus or minus, right? So our cos of x over 2 is equals to plus or minus. Remember, what is square root of 1 over 4 is 1 over 2. It's 1 over 2. So we have two things that you need to work with. We have got cos of x over 2 is equals to 1 over 2, or cos of x over 2 is equals to negative 1 over 2. So when I find the reference angle, there's no need for me to do it once, because even if I'm looking for reference angle here, because it's the same answer, so and looking for reference angle, remember we don't use a, a positive, right? So the reference angle that I'm going to get here, it will apply in both quadrants, in all the 4 quadrants, right? So the first one is going to be cos of, to find the reference angle. So the first thing that I need is to find the reference angle. What is the reference angle? It's going to be cos second function of 1 over 2, which is a special angle. It gives us a 60 degrees. Cos of 60 is 1 over 2, right? So now we've got our reference angle. For this one, we need to take it to the first quadrant and the fourth quadrant. For this one, we need to take it to the second quadrant and the third quadrant, right? So I will start with this one, taking it to the first quadrant. So taking it to the first quadrant is going to be x over 2 is equals to 60 degrees plus 360. So 360 degrees dot k, and then k is z. Then I can multiply both sides by 2. Just multiply anything by 2. So it's going to be x is equals to 120 degrees plus 720 degrees dot k, and then k is z, right? So the second general solution, remember, is the fourth quadrant, right? The fourth quadrant is 360 minus. So it's going to be x over 2. Remember, I use the same angle that I have, which is x over 2 is equals to 360 degrees minus 60 degrees plus 360 degrees dot k, then k is z, right? So this is going to be 300, but I need to multiply everything by 2 again. So it's going to be what? It's going to be x is equals to, this is going to be 300 multiplied by 2 is going to be 600 degrees plus 720 degrees dot k, and then k is z, right? So that is our second quadrant, fourth quadrant, right? But this is our second general solution. So let's go to the third general solution and the fourth general solution, right? So remember, we still have got x over 2 on the second quadrant is going to be what? Second quadrant and the third quadrant is for this negative, right? Second and the third quadrant is because of that negative, right? Okay, so on the second quadrant, what are we going to have? On the second quadrant, I'm going to have 300. It's not 300, it's 180 minus 180 degrees minus 60 degrees plus 720 degrees dot k, then k is z, right? So what is this? This one is going to be 120, but remember, I multiply by 2 both sides because of this over 2, right? So it's going to be x is equals to 240 degrees plus 720. I don't know why I wrote 720 here. It was supposed to be 360, right? 360 degrees plus 720 degrees dot k, and then k is z. Or I remembered why I wrote 720 is the brain. This is how the brain works. Once you write in something over and over and over and over and over again, it becomes a rhythm in your head, right? So the 720 was a rhythm on my head. That is why I wrote it there, right? I wrote it there, which was not correct, right? Okay, nevertheless, let's go to the fourth quadrant, right? On the third quadrant. So on the third quadrant is going to be the same angle again, which is x over 2 is equals to, the third quadrant is 180 degrees plus 60 degrees plus 360 degrees dot k, and then k is z, right? So now we're just going to multiply by 2, right? So our x is going to be what? 180 plus 60 is going to be 240, multiplied by 2 is going to be 480 degrees plus 720, sorry, plus 720 degrees, 720 degrees dot k, and then k is z, right? So there it is. We found all our 4 general solutions. Remember, it was true for each solution, right? This is the fourth one, this third one, and then the second one, and then the fourth one, right? Remember, we didn't need to find 2 reference angles, because even if we need to find the reference angle for this one, it's just gonna be 1 over 2 here, and we already calculated the reference angle for 1 over 2, because when you find the reference angle, you don't do the you don't do the, what do we call, you don't do the negative, right? You don't do the negative. So let's go to the next one. They're saying determine the general solution of tan of 3x over tan of 24. Okay, number 12, they want us to find the general solution, right? Number 12, they want us to find the general solution of what? They want us to find the general solution of tan of 3x, over tan 24 degrees minus 1 equals to 0. Remember, we need to make, because our angle is this one that we need to find general solution of is x. So we need to make this subject of the formula. So we'll take 1 to the other side. So it's going to be tan x over tan 24 degrees is equals to 1. Then we can easily cross multiply. Then it's going to be tan 3x, not x, right? It's 3x. Tan 3x is equals to tan 24 degrees, right? So now we know that our reference angle, to find the reference angle, this one is a number, right? You can just punch it into your calculator to give you a number, but I know that we don't need to punch it because of this. This is the skill that you should take as well, right? To find our reference angle, remember, to find general solution, we need a reference angle, right? To find the reference angle, I know that I'm going to use tan second function of what? Our ref angle is equals to tan second function of what? Of tan 24 degrees. So you can punch this into your calculator. Your calculator will definitely give you your 24 degrees. All right. So there was no need for us to change this to be a number, because we can just use it when we find our reference angle. Then it didn't even round it off, right? So once you have changed it, you are gonna go to a number, and then when you round that number off, it was not gonna give you exactly 24, right? It was going to give you something else, right? Okay. So let's go and find our general solution. Remember, this is what? This is positive, right? Tan 24, you should have to verify that tan 24 is positive, right? Tan 24 is positive. Okay, so let me find tan 24. In fact, let me find tan 24. Tan 24 is what? Tan 24 is 0.45, right? It's 0.45. So tan second function of 0.45 is going to be 24.22. So someone will be working with 24.22 is fine. You're going to get the correct answer, right? You are going to get the correct answer even if you are working with 24.22, but the real answer is 24. But you need to understand that tan of 24 is a positive. Without understanding that tan of 24 is a positive, you will make a mistake. You will go to the wrong quadrants, right? But here we understand that tan of 24 is a positive, right? So now we go and find our answers. Sorry, I've put my phone in the wrong way. Okay, so now we go and find our answers. So to find our answers, we know that we're going to the which quadrants? The first quadrant where tan is positive is first quadrant, and the fourth quadrant, right? And the third quadrant, first quadrant and the third quadrant. So on the to find this angle, we go to our quadrants. We know that tan is positive on the first quadrant and on the third quadrant. So the first quadrant is going to be, remember, our angle is 3x. So on the first quadrant, it's going to be 3x is equals to 24 degrees plus, remember, the period of tan is 180.k, and then k is z, right? Then we can easily divide by 3. So our x is going to be 24 divided by 3, 8, 16, 24, right? So it's 8 degrees plus 60 divided by 3, 180 divided by 3 is 60 degrees, right? Dot k, and then k is z, right? So there we are. Our x is 8 plus 60 dot k, k is z. So let's go to the third quadrant. On the third quadrant, remember, our angle is 3x is equals to, our third quadrant is 180 degrees plus 24 degrees plus 180 degrees dot k, and then k is z, right? So what is this going to be? 224, but I can easily just divide by 3 so that because I don't have a calculator, this way I will easily find the answer, right? So our x is equals to 180 divided by 3 is 60, and 24 divided by 3 is 8. So it's going to be 68. I was not going to get this 68 without a calculator, right? Plus 60 degrees dot k, then k is z. So that is our second general solution. So I've got my two general solutions. I am done with the equation. All right, I'm done with the equation because I needed only two general solutions. Remember, to make a second function here, you need to firstly understand the quadrant, whether this is a negative, whether this 24 tan 24 is a negative or a positive, right? Because you don't need to put a negative here, right? You don't need to put a negative when you find the reference angle. Okay, so now let's go to the next question. The next question is what? The next question says consider f of x is equals to sine of x plus 25 cos of 15 minus cos of x plus 25 sine of 15. We have agreed that this is a compound angle of sine, all right? And then they say determine the general solution of f of x. So we know that they are saying f of x. Okay, firstly let's simplify f of x, right? Let's simplify f of x. So we know that this is number 13. We know that f of x is equals to sine of is it x plus 25? Yes, it's x plus 25 degrees, and then cos of what? Cos of 15 degrees minus cos of x plus 25 sine of 15 degrees, right? So there we are. So this one, to simplify this one, we know that it's going to be f of x is equals to, so this one is a double angle, or it's a compound angle of sine, so it's going to be, or the one with a minus here in between, right? So it's going to be sine of x plus 25 minus 15, right? Minus 15 degrees. So this one is going to be our f of x is sine of x plus 10 degrees. So that is our f of x. So they are saying f of x is equals to tan 165. So therefore what they mean is that sine of x plus 10 is equals to tan of 165 degrees. So is that a special angle? 165 is 80 minus 15. So 15 is not really a special angle, right? 50 or 75 is not really a special angle, okay? But we need to find a general solution. So with this one, we can change it to a decimal. But if you don't want to change it to a decimal, you can easily find a reference angle. So to find a reference angle, you know that this is negative, right? This is negative because it's on the second quadrant. This is on the second quadrant, so tan on the second quadrant is negative. And remember, you don't put a negative when you find a reference angle. So you can easily just say sine of negative tan of 165 if you don't want to work it out, right? Or if you want to work it out, you can work out this one and say it's the same as, or this is 180 minus 15. So this is the same as negative tan of 15 degrees, right? This is negative tan of 15 degrees, right? So you can easily come here and say tan of 15 degrees, right? So this way, I think this way is more understandable, right? So you didn't have to round off anything because I usually don't want to round. I don't like to round off things before I go to my answer, right? I usually do not like to round off things before I go to my answer. So what is the sign of this one? Sine second function of tan 15. Sorry, I forgot to show the second function here, right? Sine second function of tan 15. Okay, sine second function of tan 15. Remember, this is the first time I'm using a calculator since we started with this question. Okay, so I'm just breaking there. So what is tan second function of 15? Sine second function of tan 15 is going to be 15,54. So our reference angle is 15,54. Our reference angle is 15,54. 15,54. 15,54 is 15,54 degrees. But I heard that Apple Intelligence have got a calculator here. Maybe this thing can give me a calculator. What does it do? Nope, it doesn't give a calculator. It's fine. Okay, so now we've got our reference angle and we know that it was a negative. So sine is negative on which quadrant? Sine is negative on quadrant number 3 and 4. Right? Sine is negative on quadrant 3, number 4. And then our angle is x plus 10. So I've got x plus 10, taking it to the third quadrant. It's going to be 180 degrees plus the reference angle, which is 15,54 degrees plus 360 degrees dot k, then k is right. So we take 10 to the other side, it's going to be minus, right? So our x is going to be 185,54 degrees plus 360 degrees dot k, and then k is right. And then we go to the fourth quadrant, which is going to be x plus 10 is going to be 360 degrees minus 15, which is our reference angle, 15,54 degrees plus 360 dot k, and then k is all right. So after this, we take 10 to the other side, so it's going to be 25, right? So I've got x is equals to negative 25, so it's going to be 334,46 degrees plus 360 degrees dot k, then k is I'm sure this one is correct, but you can verify it. And in fact, I think the next question will need it. So if the next question need it, let's verify it. So it's going to be this is going to be 25,54 minus 25 is going to be 34. Yes, it's correct. Correct answer. So the next question, they say determine the value or values of x in the interval from 0 to 3 sig t, for which f of x will have an minimum value. F of x will have a minimum value. Oh, determine. They say determine, right? Determine. Okay, I'm going to use the skills that I have with a sine graph, right? Sine graph. The skills that I have with a sine graph. The skills that I have with a sine graph. I know that this is the sine graph. Sine of 0 is 0, right? Yes, sine of 0 is 0. So this is the sine graph. The skills that I know about the sine graph, this is 0. This is 90. This is 180. This is 270. And then this is 360 degrees, right? So those are the graph of sine. So they say values of x, the value or values of x on the interval from x is an element of 0 to 360, where f of x will have a minimum value. Remember, the minimum value is this one. So the only minimum value is that one, right? So now remember the graph of x. F of x is sine x plus 10. Is it plus 10 or minus 10? Let me confirm. Plus 10, which means plus 10 is shift to the left. So shift to the left, this one is going to move this direction. So from 270 shifting to the left is going to be x is equals to 270 degrees minus 10 degrees, which is equals to 260 degrees. So let's talk about marking allocation for this one. Understanding that the minimum value was at 270, understanding that shifting is 10 units, and final answer. So this is perfectly 3 marks, right? So it's just 270 minus 10 is equals to 260. You will see this in the memorandum and say, yeah, what the fuck? Wait, sorry for the language. Okay, you will say, what's going on here? 270 minus 10 gives us 260, and then 3 marks. Yes, it's because you had to understand the function. It showed that you understand your trig function, right? You understand your sine graph, right? So the sine graph is from 270 to about the minimum value, and then you apply it, and then that's it. Then we are done with this question. and then we can look forward to the next questions. All right, we are done with this question. We can look forward to the next questions. I will post them soon. I don't think, okay, I'll start by physics, but this one, it was very easy, guys. This class, I think this session was very good. And then you can leave me in the comments if you feel like there's something that you need help with. But if you want to join the classes, please don't hesitate. Just tell me, say I want to join your class. I will let you in. I will hook you up, and then it was going to be very exciting. You will learn a lot, right? You will learn a lot, and then you are definitely going to improve. That is no, there's no question. You are going to improve. Thank you. Let's see each other on the next video.